Welcome to the Deep Dive. Today we're venturing into a really fascinating space, exploring excerpts from Bionic Chaos, interactive biomedical tools and simulators. Our mission for this deep dive is basically to show you how these incredibly complex biomedical concepts can become, well, not just accessible, but surprisingly hands-on and even, fun. It's almost funny, isn't it, how engaging something so intricate can actually be?
That's absolutely right. Yeah, it's really about transforming that sort of passive learning into active exploration. It offers you this unique sandbox, to play in for understanding the human body and the technology that interacts with it.
Okay, right. Let's unpack this a bit. Imagine just trying to really get complex physiological data without seeing it move, seeing it react. These Bionic Chaos tools are not just static dashboards, they're more like dynamic learning environments. We're talking about tools where you can, practically play with brain waves or fine-tune heart rhythms. It sounds wild.
It is pretty wild. And what's fascinating here is how they take this raw, often really intricate data and turn it into these engaging interactive experiences. So for instance, you've got the modality comparison bubble chart. It visually compares different physiological and sensing modalities based on their temporal and spatial resolution.
Okay.
So like speed versus detail and location.
Yeah.
It gives you a great visual starting point.
Right, a baseline. And okay, here's where the simulators really come into their own, I think. We're talking about tools like the Advanced EEG Signal Simulator. Here you can actually customize brain waves, delta, theta, alpha, beta patterns, and you can even simulate artifacts.
Artifacts, yeah, those unwanted interferences,
Right.
super important.
Exactly, for a complete picture.
Precisely. Or you take the ECG simulator. That lets you explore various cardiac rhythms, see the effects of different electrophysiological parameters directly on the ECG waveforms, which, it raises a really important question. How does actively simulating these vital signs deepen understanding compared to just, say, reading about them in a textbook?
That really is the core of it, isn't it? It's the interactivity. It gives you that immediate feedback, cause and effect right there. You're not just reading, okay, if X happens, Y occurs. You're making X happen and seeing Y occur, instantly. And I think this active experimentation is also why something like the synthetic noise generator dashboard is so valuable. You might just think, oh, noise is noise, right?
Yeah.
But here you can generate and visualize different types, white, pink, brown, even periodic noise, and really understand how they mess with actual signals.
Yeah, and that's crucial because in real-world biomedical data, noise is a huge challenge. So understanding it interactively, that really helps with cleaning data, interpreting it properly. And if we connect this to the bigger picture, it's really about making these abstract concepts tangible. Think about the cochlear implant simulation. You can literally visualize the electrical signals sent to the brain, adjust parameters, see what happens. Plus, there's even an interactive cochlear implant insertion simulator. You can explore the actual mechanics of putting the implant in. It's built using 3.js and chart.js. Pretty neat stuff.
That's incredible. It's almost like having a virtual medical lab right at your fingertips. Honestly, it makes me think back to college, struggling with some of these concepts. If only I'd had a tool like this back then to actually see the changes, Does that hands-on experience really cut down the learning time?
Oh, absolutely. That immediate feedback loop, the direct manipulation, it just accelerates how you build intuition.
Yeah.
Massively. And for people curious about real-world stuff and thinking critically, there's the Epilepsy and Cardiac Health, an interactive evidence review. This lets you dive right into the research, compare, say, anti-epileptic medication effects, look at different study methods.
That's fantastic for getting into actual research data. Oh, and for the real data explorers out there, the Interactive Explorer, public multimodal biomedical data sets. Sounds like a gold mine. Sifting through real EEG, ECG, PPG.
Let's go in IRS signals.
Right. FNIRS, functional near-infrared spectroscopy, that non-invasive brain activity measure. And from there, you can even explore using advanced analysis machine learning for things like seizure detection with tools like RhythmScan.
Exactly. It's not just about passively consuming information anymore. It's about becoming an active participant. You're analyzing, questioning, testing hypotheses, all without needing a physical lab right away. It empowers you.
So wrapping this up, what does it all mean? I think this deep dive into Bionic Chaos really shows us that understanding complex biomedical engineering, it doesn't have to be this daunting mountain to climb. It can actually be incredibly hands-on, engaging, and surprisingly fun. It turns potential frustration into real discovery.
Well said. Knowledge is really most valuable when it's understood and applied, right? These tools empower you listening to not just consume information, but to interact with it, to experiment, and to truly grasp the intricacies of our biology and the tech designed to help us understand it.
So here's a final thought for you to ponder. Imagine if all learning could be this interactive. What seemingly impossible medical or scientific challenge might you feel equipped to tackle just by being able to virtually play with the problem and its data? Something to think about.
Everything we do is available freely on bionichaos.com. Please consider supporting me on Patreon, and don't forget to click like, subscribe, and comment.